Let's discuss question number 6 from test 1. Let's read the question. A metal wire of length L, area of cross section A, Young's modulus Y behaves as a spring with spring constant K, and we are asked to express K in terms of Young's modulus, area and L. So basically you have a metal wire, which I'm just writing it as a cylindrical rod, okay, of length L, area of cross section is A, Young's modulus is Y, and now if this behaves as a spring, so obviously any elastic member when you apply load will expands a bit, okay. If you apply an axial load, tensile load, it expands. So it's basically a property of elastic material. So by Hooke's law, stress is proportional to strain by means of your Young's modulus, and this is the Hooke's law equation. Within the elastic or within the proportional limit, any material behaves in this way. Now stress is your load P by A, area of cross section, axial stress. Young's modulus is given as Y here, so let's represent by Y. Strain is, let's say it expands by delta, so delta by original length L. So P is basically expressing A Y by L in terms of delta in this way. Now he says that this wire behaves as a spring. And what's the property of spring? When you apply load P, it expands, and the deflection is, say, delta, and deflection is expressed in terms of P by stiffness. So basically spring stiffness is defined as load per unit deflection. This is a definition of spring stiffness. Now what he means in the problem is that a wire behaves as a spring. So basically for the same load P, if the expansion is delta, so in that way you can basically equate, or you can, and you are asked to consider a metal wire as a spring. So the external behavior remains same for a given load P. If the expansion is delta, then what is my stiffness in terms of wire parameters? Okay, so from this, so equating this first and the second equation, we can just equate the load. So what we get is AY by L delta is K delta, and K is AY by L. So looking at the options, it's A. Thank you.